You can solve some absolute value equations using mental math. For instance, you learned way back in lesson 2.1 that the equation, the absolute value of x equals 8, has two solutions. That x could either be 8, but x could also be a negative 8. Because inside the absolute value symbols, then if you apply those symbols, that value becomes 8. To solve absolute value equations, you can use that fact that the expression inside the absolute value symbols can be either positive or negative. Okay, I'm not sure why that just blackened out there, but so to solve the absolute value of x minus 2 equals 5, we're going to go ahead and we're going to apply that, and we have to solve it in two different ways. We will solve, first of all, if x minus 2 equals 5 is positive. And we can also solve, whoops, let me fix that a little bit. That's still not good. Let's start over. X is positive, or if x minus 2 is equal to a negative 5, because the x minus 2 is inside the absolute value symbol. So that could be that that value is either a positive or a negative. Now I'm just going to solve like I solve any algebra equation. On this one, I'm going to add 2 to both sides, giving me that x is equal to 7. And on this one, same thing. Whoops, I'm a little sloppy here. Whoops, lost my 7. Okay, I'm going to add 2 to both sides. However, because this side I'm solving for a negative 5, when I combine negative 5 and positive 2, I get negative 3. So my answer there is that x is equal to 7 and that x is equal to negative 3. And I could check those solutions. 7 minus 2 equals 5, and negative 3 minus negative 2 does equal negative 5. If I put them into their absolute values, 7 minus 2 is 5, and the absolute value of 5 is 5. And if I put it as negative 3 minus 2 equals negative 5, and then I do the absolute value of that, the absolute value of negative 5 is 5, which brings me back to my original statement. So this time we're going to solve an absolute value equation, a little bit more difficult because it's a two-step equation. Now, be careful because the absolute values, we'll give you a yellow here, caution. Be careful because the absolute value symbols only apply to the 2x minus 7. So what I need to do first is I need to go ahead and make this just a regular algebra sentence, and I'm going to put my constant terms together. So the first step I need to do is I need to add 5 to both sides. So 2x minus 7 minus 5 equals 4. So I'm going to add 5 to each side. I'm not dealing with the simple absolute value statement that I had, equation that I had in the last example. So now I have only my absolute value on this side of the equation, and I have that equals 9. Now I am to an absolute value statement, so I can go ahead and I can do the same as I did in example 1, and I can say 2x minus 7 equals 9, or that 2x minus 7 equals negative 9. I'd solve these the same as I solve any equations. Let's go ahead and add 7 to both sides, giving me 2x equals 16, or x equals 8 when it's simplified. And on the other side, remember, now I'm going to have a negative here. So I'm going to do the same process, add 7 to both sides, like dividing 7 there. And I would end up with 2x. But this time, 2x is going to equal a negative 2. I'm going to get my little dots instead. negative 2. So divide both sides by 2, and x is also equal to negative 1. Okay, so the caution, and I can tell you this from last year's class, the mistake that was most often made was not adding the 5 first. You need to, when you're solving and saying it could be a positive or a negative, that's only applying to the absolute value symbol. So you need to make sure that you're getting the other terms together. So moving on to example 3, we're going to solve absolute value inequalities. Now this is a little bit different because remember we have the one problem is we're going to, or the one concept that we have to remember is if we're multiplying or dividing by a negative, we're going to reverse the sign. So you can go ahead and you can come back to this equation. I'm going to go to I'm going to go ahead and I'm going to go to the example, and then we can come back to all of the rules that we have about this. So the absolute value of x minus 4 is less than 3. So I'm going to do the same as I was doing when I was talking about equations. I have only the terms that are in the absolute value, so I can go ahead and say that that's going to be a positive or a negative. So I'm going to say that x minus 4 is less than 3, but this time I'm going to say that it could also be negative. And because it can be negative, I'm multiplying by a negative. So I need to say that x minus 4, and this time I need to reverse the sign, and then I can say that value could be a negative 3. I'm reversing the inequality symbol because I'm solving for the negative version of that absolute value. Then we go ahead and do the same basic algebra that we're used to. And same over here, but we have a different value. So we have x has to be greater. Negative 3 combined with positive 4 would give me a positive 1. Now this equation I can then write as a compound sentence because, or a compound inequality statement, because x is going to be greater than 1 but less than 7. Okay, and then you know how to graph that too. Did the last one say then graph? No, it didn't say then graph. This is the next example. So we're going to go ahead and I'm going to move my graphing here for a minute. Get that out of the way. And first step again, here's that caution. Make sure that I only have an absolute value statement there. So my first step, after I get my black marker to come back on, is going to be to add 3 to both sides. Now I'm just adding 3, so there's not any multiplying or dividing going on yet. So now I have the statement, just the absolute value statement, and I have that that's greater than or equal to 9. Now I can go ahead and I can solve for the positive or the negative. So the positive would just be the statement 2x, plus 1 is greater than or equal to 9. And then the other side, I'm going to apply the, as I'm trying to press a little harder, so I'm not getting the dots, I'm also changing the magnifying of it. And now because I want to solve for the negative 9, I multiply the 9 by a negative 1, so I'm going to reverse the symbol. So this time it's going to be that it's less than or equal to a negative 9. Okay? Same solving. 2x. Oh, let's do that over. I don't like the... Try that again. 2x is greater than or equal to, and we have 9 minus 1, so that's going to be 8. Divide by 2, divide by 2, and I have x is greater than or equal to 4. If I look at this side then, subtract 1 from both sides, I have on this side 2x less than or equal to negative 10. Divide both sides by that 2, and x is less than or equal to a negative 5. Now we were supposed to, let me just shrink this back down a little bit, also graph this. So let me get the line graph up here. I'm just going to put it over the original. Whoops. I pulled it right off the board, didn't I? Okay. So if I do this now, I'm going to say x has to be greater than or equal to 4. So you can see that it's a solid point, and it is shaded to the right. My other equation, or my other inequality statement is x is less than or equal to negative 5. So again, because it's an equal to, it is a solid point, and that point is then shaded to the left, following that inequality symbol. So if we were going to write an absolute value inequality, we're going to use a little bit more of a real life situation here. You work in the quality control department of a manufacturing company. The diameter of the drill bit must be between 0.62 inches and 0.63 inches. So if you write the absolute value inequality to represent this requirement, it would look like this. Our value needs to be between 0.62 inches and 0.63 inches. It can be larger than the 0.62, but it has to be smaller than the 0.63. So if we move to the next, oops, I'm going to slides, possibly not. There we go. So if we go ahead then and find the halfway point between the two of those, that would be 0.625. So if we find the halfway point is 0.625 and we subtract that from each part of the compound inequality, we can rewrite the absolute value inequality as d minus 0.625 is less than or equal to 0.05. So this inequality can be read as the actual diameter must differ from 0.625 inches by no more than 0.005 or 5 thousandths of an inch. So when we go to the next screen, there we go. So if the bit is 0.623 inches, does it meet the requirement? So we need to see if 0.623 would fall between the required diameters. So we go ahead and we put the 0.623 into our diameter minus the 0.625, and we need to say, is that less than or equal to 0.005 or 5/100ths. So because it is smaller than that, then we can say, because it's 0.002, and that is less than or equal to 0.005, that does meet the requirement. And that concludes 6.4, bringing absolute value and both equations and inequalities into the concept of absolute value.